Hello everyone. So let me share my screen. Yeah, I hope it is visible now. Okay. So today we will see that is one point in the PVsyst that is most probably used is grid connected system and how to design it. Even we will see some near shading and how to add objects and all this stuff. Okay, so let's go to the PVsyst here and you can click on grid connected system. Now, when we are saying grid connected system, the load definition is not a issue because we are dumping entire things into the grid. So we can consider it is kind of infinite load. So whatever the things we are dumping it inside the grid, it is being utilized. Okay, so again, here I'll keep the name as it is new project. I'll select the data again. See, you can see this is the Pune data. So like yesterday, and sorry, and the data set, as I mentioned, for the Pune in 1990 been considered here. Now again, orientation. So today we will go for the fixed orientation first, then we will change the orientation and we will see what are the effects on that one. So again, I will keep the orientation part as it is. We'll keep it uh, let's say 23-degree annual yield likewise, and we will keep the orientation right now as a fixed. Then we will see what is the change and all the stuff we can do. Then about the system. Now today we will define our plant power. So normally people will go by the two ways. First thing is whatever the available area with me in meter square. So we can define that we have available area of this much, or we can go by the plant power. Now here I will just define what is the basic plant power minimum requirement is 3 kilowatt. In India, if you want to set up a plant, minimum plant, solar plant, so inverters and all the systems are available with a 3 kilowatt only. So that's what I have kept it the 3 kilowatt. Here we will change the panel because just to show you that here the Yagli's panel, we will select some module. Let's randomly pick something. 300 or 3, yeah, I'll go with the 300 panel. Okay, or we can go with the maximum one. Is it possible? Okay. Okay, so I have selected some random panels here, and you can use that one optimizer also. But right now we will stick up to that one. Okay, so 3 kilowatt system is there, 330 watt peak 28 volt panel we are going to select today. Is it a bifacial system? Bifacial means it should have both sides there are solar panels. Right now we are not selecting that. We will see that afterwards. And again, inverters we need to select. So I would suggest just to select the inverter of 4 kilowatt. The reason, see, whenever we add the losses or whenever we add some additional parameters over there, it is kind of creating some issues over there. Or sometimes it is possible in India especially that your input irradiation is more than 1000 watt per meter square. So what is the standard test condition? Your input is more than 1000 watt per meter square. Temperature of the panel is 25 degrees Celsius and there is a no shading. So in India, we have tested the with the paranometer what is the input. So sometimes in the summertime we are getting the more than 1000. It's quite easy, or it is easily available in India. So that's what there is a saying that if you are installing the 3 kilowatt plant and selecting something little bit higher inverter, it's okay. I'm selecting the 4 kilowatt, it's not that much. Here we need to select that the sharing within inverter is there, because that's what we need to check. Now, first thing, only one inverter is required. The first thing, check the operating voltages. It is in the range of 30 to 550 volts. Now, if your operating conditions are, like say, at VMP 60 degrees Celsius, it's 258, MPP 20 degrees 304, and -10 is 395. So if these conditions are not match, so it will show you the error. Right now, what is the warning? Not error. The inverter is slightly oversized. I know that I'm selecting something. Now let's go with the less size. You'll see that what is the change. Now we are going with the less size inverter. Now you can see that the array MPP voltage may not attend the inverter minimum voltage, full power. So it is giving me error like that one, or warning like that one. So that's what I'm selecting, something inverter size little bit oversized. That is okay. Here the array we can select something like that. It is showing that 2 to 13 anything array you can say for that one. And the other things we are saying, like, okay, here the available area for that one is showing it's 15 meter square. Okay, and how many panels we required it is mentioned over here, or 12 panels are required over there. Here it's here, the number of modules on the left hand corner, 12. Module area is 20 meter square. Number of inverters, 1. Nominal power and AC power, that is the mentioned things are there. If you want to see the system overview again, okay, sorry, that single line diagram. So you can see that is a string, the inverter, and that is a system single line. We can see that one. Okay. So right now I'm clicking OK on that one. It will show you the warning, not an error. Inverter power is slightly oversized. So I'm saying it's okay, because even if it is showing some warning, I can go ahead with that. Now with this data, it is saying that ready for simulation, but we will add some points now here. Now, detailed loss, as discussed yesterday, we will give some data here. Ohmic loss, again, we will select some default values, LID and all this stuff. We are selecting some default values. Okay, there's some energy losses at somewhere. So right now we don't want that one. Aging is one of the factor. Again, I'm not using anything. Aging means, see, your panel decreased day by day, a small value. So here we can define that what is the degradation rate and all. So mismatch and all. Mismatch means, if I'm saying my panel is 300 watt, so how much we can achieve in say after 5 years, how much mismatch is there from 300 to the actual value. So that is the mismatch one. There is one parameter is called unavailability. It means that the system is not available. Normally we can say it for the maintenance sake or something, we can switch off the system. So that also we can define some days, or that these are the points where the system won't be available. Maybe maintenance, maybe some shutdown, maybe some fault occur at the system side, so we need to close down the system. So that is the part unavailability. So I'm selecting the default right now, and spectral collections we are keeping as it is. So these are the losses, we need to add it in the system. Then there is a point called self consumption. See, the grid connected systems means we are assuming that whatever the solar energy generated, electrical energy will be dumped into the grid. But there is a point that sometimes it is possible that we are using some of that energy, means solar energy we are using it some of partially, and partially we are dumping into the grid. So for that particular one, we can use this particular point, then how much we are using and all this stuff. But right now I am saying that okay, there is no self consumption, so I'm okay with that one. Again, storage, it is called grid connected system with the battery storage, that it is connected to the grid, but we are storing into the batteries also. So that part, again, I'm not going in details. So the points we are going into the details in this optional one. Let's see that. Yesterday we have seen that horizon point. So as I mentioned that we will discuss in the detail with the grid connected system. Okay, so this is the horizon, means it is showing actually the solar path, and there is a point where we can go here. Now I have given Pune location, means some latitude longitude is already with the system, that this is my point of installation. We can go into the deeper and we can give some details data also. So here what I can give, I can give, ask the horizon based on this latitude, that 18.5300 and 73.8500. Based on this latitude, I can import some data from the web. So if I click it on this one, yeah, I'll just show you this red line right now. It is exactly lying on the x-axis. Now after importing, you will see some changes over there. So it got imported. So you can see there is a slight changes in the red line, means depending on some data on the given location, it is grab some data over there. Now there is a possible we can have the other data also, means there are some other sources also for that one. So I'm just importing data from that. Let's see, is there any changes out there? Yes, there are some changes there. Discrete data is there. Now what this particular data suggests that, see, there is a timing you can see over there. You can see it on this side. There is a timing 1 o'clock, 2 o'clock, 3 o'clock, or say 13, 14, 15. These are the timing over there. So this particular time, there will be the shadow over the solar panel for this particular time. I can show you like this way. If I can bring it here, so from let's say 2 o'clock to 3 o'clock, my solar panel will be under shadow because of this particular object which is far from the solar panel, but that will put some shadow over there. That is called far side shadowing. So I don't want that one, so I'll close that. I'll clear this point. Okay, so this particular far side, okay, it is not there, so I'll import from some known sources only. Okay, so this is called far side far object shadowing that may affect your solar panel. Now understand why we are concerned about the shadow. When somebody can tell you that, okay, at a particular point there is some shadow of some pole or something on your panel, what will happen? That it will reduce your output little bit, nothing else. So understand, there is a concept called dark spot on solar panel. Dark spot means if there is a particular cell of the solar panel, it is continuously being under shadow because of some objects every day. So because of the shadow, all the voltage is going to fall across that cell. Means that cell is going to heat up again, and at some point after some years or some time, it is going to break down. So if the solar panels having the bypass diodes after every cell, then only it can bypass that particular cell and it can produce the output. If you see that every cells in the solar panels, whatever the solar panels we are dealing with, is all the cells are connected in series. If you shut down one of the cell in the series, it is affecting entire series. So nowadays people come up with the solution that there is a bypass diode. So even if the cell is going down, they will provide some bypass diode over there. So the shadowing things are taken care very seriously because of the dark spot. Okay. Yeah. Any question? Okay. Okay. Okay, so this is the far shading. We can see that, yeah, I was talking about dark spot. So that is also important. So that's what people are very much concerned about, how much shadow is there on the solar panel. Not because we are getting, yes, obviously we are getting the little bit less output also, but it is important that it should not be a small spot on the solar panel remain continuously under shadow. It is the problematic thing. It can damage the entire panel, and this is not good thing. Okay, and see, that's the mismatch. There is one loss we have understood yesterday, that mismatch means if we connected four panels in series, if one panel is not producing properly, means it is connected in series, so one panel voltage is not up to the mark, so that would be the lowest voltage will be the final voltage of the entire series. So one loss, it's kind of a loss for the entire things, you can understand in that way. Okay, so this is the far shading. So we'll click OK on this one. Okay, the green dot means we have changed something and it is good to go. Now yesterday we have seen this is near shedding. So what is the near shedding? Well, let's understand this one. So before this one, you should know that in your system, how many panels are there? So there are 12 panels. You can see it here. Number of modules are 12. If we can get it little bit lesser, so it would be the best one. I'll try to go somewhere. So just to reduce the number of panels. Just to show that these are the okay inside. Okay, now it is showing six approximate panels required are six, so I'll happy with this one. Just because, see, I haven't changed the kilowatt plant, I'm just changing the panel size. The three, instead of 300 I'm going for 545 watt panel, and I require six panels only. Okay, so let's understand the near shading concept, or how we can define it. I'll add one of the object only to show you near shading. So this is the box where we need to put some object or panels also. So first click on table zone. So once we click it, it is, you can see that it is showing in the 2D one. Now now go to the create and go to the rectangular PV plane. So it will add the rectangular PV panel, how we are going to set it. So here you can change something, or you can say that I don't want to set it in the one rectangular in one rectangular. I can go with the two rectangulars also. It depends on the number of panels. So you can see that it is setting up this two rectangular also. Okay, now this one box means one panel, you can understand in that sense. So the reason I am going with this one, that we need only six panels. Now here I am going with this average, that 23-degree tilt is there. Now you can see here what is the rectangular area, and this is the field area. So rectangular area, this entire area covers 20.91 meter square. The reason, there are eight panels are there. You can see that top four and bottom four. There are eight panels are there. That's what it is going for the 20.91. But actually required area is 15.4. It is written over there. You can see here 4 into 2, that is 8. Okay. Now we want little bit on good side. What is the effect on that one? So here we can change something. Here instead of 4, I'm just putting 3. Okay, so what I have changed here, now instead of 8 there are three panels each. There is a stack, upper column 3 panels, lower column 3 panels. That is the thing. Okay, even instead of landscape I can go with this module also. We can keep the panels in this way, portrait mode, or we can go by the landscape mode. So as I'm changing this one, this particular, now I can go with the sensitive size also. This is by module adjustments. I can go with the sensitive size also. So it is automatically showing me what is the height and what is the length required for this area. So 2.29 meter and 6.86 meter is required. Okay, the other things I'm not changing anything here. Landscape or portrait, that you decide which one you want. Now I'm going by the sensitive one, so I should be going with the landscape only. That's it. Even if you want to add some partitions in between, so we can. That there is a the partition between the two panels, or there are two separate ones. But right now I'm not interested in that one. So I'm okay with this one. So I'm saying close the object. So this is my solar object. Solar panel is there of six panels. There is a bunch is available here. Okay, now let's see what is the effect of some element. So let's add some element here. Instead of we'll know some known object, let's say tree. So whenever we say tree, so it is coming with some defined parameters. I can change this one. Let's say it's make it 3 instead of 3, I'll make it 3.5. So you can change what is it's going to change it here. The trunk height I can make it, let's say 3 meters, so it will be a little bit longer one. And the medium diameter, or something, that I'm going to change it to 3.5, or let's say 3. I'm just putting some random values over here. Yeah, you can actually measure the values. If you know the some construction, fixed construction is there, you can actually add those also. Means here you need to decide if there is a house or if something is there, or you can draw also if you want. So I'll set some parameters here for the near objecting and I'll close it. So you can see there is a tree addition is also there. If I go for the tools again, no, sorry. Okay, there is a tree addition. We will see that pane, that side view and all afterwards. Okay. Now, where is that tree exactly? Where it is? How much away from uh, the panel set? So here we can go here with the pan hand, and we can click here, and we can say move. So move object means we need to move here and here somewhere like that. Now you can see that first thing you should understand. This is azimuth angle. These panels are facing to the south. Now south direction is the downwards here. So these are the facing south. So what I'm going to do, I'm keeping the tree here exactly facing south with some distance again with the plant, and we are keeping some tree here just for even if you want to measure what is the distance, you can check the distance between these two. Based on that one also you can get it. So this is the distance between the 2 points. Based on that also we can decide, but right now I'm not interested in the measuring. Okay. Okay, okay. Okay, I'll close this one and I close this one. Okay. Okay. Right now I'm just keeping my tree over there in front of the panel, and I'm closing the scene. Now I need to check that what is the effect of this particular tree over the entire year, how much it is affecting on my panel. So to get that one, you need to just click on the table button and it will compute entire things. Okay. Now, just getting the point. See, whenever it is written behind means the panel is going behind the uh, that particular tree object. Okay. Here you can see that some numbers are there. Zero means there is no shadow on the particular panel. Here some numbers. These are the diffusing the radiations coming on the panels, and based on that one we are getting the values. Now we want to see. I'll going to recompute also. Okay, these are the fix. Now how we can say that how much effect is there? You can see it on the graph also. So this is my solar trajectory, and these are some black lines. You can see these are nothing but the shadow due to that tree, or the different months, or the different seasons, we can say duration, different durations. Okay. So this particular things telling you that okay, this is the problematic thing. So there is a shadow starting from the afternoon 2 also. So my panel will remain the partially shaded from 2 to let's say 6 o'clock or something like that. So this is the problem. Okay. So that is the effect of this particular near time object. See, we can define the object, we can define the solar panel where we are keeping the solar panel. Even if it is slanted roof, we can define the roof, what is the angle and all, and we can set the panels, and we can check is there any effect of the nearby objects that putting shadow over the entire year. So this particular feature of the PVsyst is it makes the PVsyst little bit good compared to the other softwares, that the shadowing effect. Okay, so again I'll go back here. Let's change something here. So let's go to the tools and let's get the pan. I'll ask it to move, and let's move the tree away from the solar panel, but in a different direction now. Okay, so I'm keeping the tree now. It is not south facing one, but I'm just keeping on the little bit on west side to the plant. I'm closing this one and I'm asking it to the recompute this one. So let's see, is there any effect of this one? Now you can see that whenever I'm keeping it on the west side, so in the morning session there won't be any problem, or the entire year there won't be any problem. But in the afternoon session there are black lines are there, means there is a shadow coming over the solar panels. So that is the particular points we should understand, that near object shadow is the really important one. And See, look, sitting on the one place and in the one point of the time, we cannot say that there won't be any shadow in the over the entire year. The shadows will be the long enough for this winter season, and shadow are the shorter one for the summer season as the sun is coming over the top. That's what. So we need to analyze those things while setting up or while installing the plant. If we are saying that there won't be any shadows in the summertime, it's good. But if due to some objects the winter time will be it's putting shadow on your panels, it is first thing, as I mentioned, it is giving you the lesser output. Second important thing, the dark spot effect, that is the problematic thing for your system. So let's see, I'll keep the this particular object out of the way so that we'll get the maximum one. I'll keep it a little bit away or like that one. And let's see, is there any effect on that one? Okay, so yeah, now you can see that there are only the effect, but these are going out of the way. After 4 o'clock, there is some effect of this particular shadow on the panel. Yeah, let's assume that it is there. So we will compute the things based on this one only. Okay, now here again you can define the panels. As I mentioned, you here you can define the system, you can define some, you can actually draw some system, you can draw some images, you can draw, put your panels over there. In the full version PVsyst, you can actually go to the Google Earth or Google Maps. From that one, you can go to the Google Earth and you can actually set up where exactly you want it in the entire world. You can have the Google Map with you, so you can set up the plant over that. Okay. So right now, let's assume that that is the system. So I'm not going to change this one. So I'll go with the this as a near shade. Okay, now once I had done with the near shading, there is a model layout is there. Now layout, it is just showing this is the we have only one row. So when we are going for the bigger plant, so you can see there is a lot of rows are there. As I have shown you that you can add the number of tables over there, rectangular tables, so you keep on adding. So depending on what is the size required and all this stuff, we can decide that one. So right now, layout, we have nothing in this one. So it is just showing that one row is there, nothing else. So I'll just close this one. And energy management, this is again, if you want something, if you know some temperature related data and all. So second thing, the power factor, what is the power factor, we need to use it for the grid injection. If we know this entire things as it is, otherwise we can say that let us assume this is the one or this is the ideal side one. Here we can say that we can put some limitations on the grid dumping. So yeah, even in the Maharashtra region, if you want to install our plant, solar plant at our home, we need to take care that how many people near my home or in my area are using this particular facility, because the MSCB will check that how much dumping is there, and they can limit some dumping on their side, that you cannot dump beyond this particular one. So you can use it for your battery charging, or you can use it internally self-consumption as we are seeing. So that also we can define here. And this is little bit estimation side. So we'll see that afterwards once we simulate the things. So P50 and P90, you can see that there is a estimation based on some hypothesis. We'll see afterwards. Okay. Now with this one, we will run the simulation first, and we'll do the economic analysis afterwards. So before going ahead, is there any issue or problem you have? You can ask. Yes. No, see, uh, the limits. I know the one of the case limits. I have observed that case. That's what I can give you the idea. I was working in the COG now. in COA we want to set up some plant. We have the lot of area available with us, but there is an issue that there is a Sancheti hospital nearby. So these people are also coming up with the solution that they want solar power. Now, whenever we are dumping into the grid, what is the transformer nearby? What load it can handle? That particular capability also we need to take care. Means that is not our job. That is the MSCB job, because once we are connected, before meter part is all belongs to the MSCB. So everyone will take care about these particular parameters. We are dumping that particular current is going somewhere, and it is first going to the nearby the objects or nearby the transformer, we can say. So once we are dumping it to the grid, so we need to check that is it not overloading any of distribution system, so that it can cause problem. Okay. Net metering means we are that's the one of the meter we are setting up. That just calculating what is the internal or say incoming current and outgoing current. So that is the netting. But while dumping the current into the grid, we need to take care that it should not harm any of the distribution system nearby. That's what some people make means nowadays the government is promoting technology and all this stuff. So they are coming up with the solution that okay, every system should be capable of those things. But you ask the MSc engineer nearby, I want to install the system. He will first check those parameters. Then only will allow or it will sometimes I can give you the answers regarding region. Some regions people are not allowing to set up the renewable energy because of this technical reasons. If they upgrade their system, distribution systems, it's good. But if they don't upgrade or they cannot upgrade, then they will stop the people from installing on renewable energy. Or they can just directly that if you want to use it, then use by your household system only. Don't need to become the grid. As per the Maharashtra government new rules, 20% energy generation should be from the renewable sources. So if they satisfy that particular 20% they are happy with the things. That's what there is a great limitations are there. In some regions, in some areas, there is a possibility. But nowadays the government coming up the solution that don't we want the renewable system. That is the thing. Okay. Sorry. So let's run the simulation first and then understand Kulkarni things that we. So we have run simulation like today we are getting performance and all that stuff. So what is the system production for year? You see that 56411 kilowatt per year. What is the number of production size and some losses are there in considered and all the stuff. Okay. We have some tables, we have some graphs also. So I'm not going that one. Right now we will do some economic evaluation. So what is the economic evaluation now? We need to understand how much money we are invested in, and payback means in how many years we are getting it back. And this is the really good calculation that PVsyst provide. That payback rate. So let's do some economic evaluation. So while we have selected only two parameters in the PVP module, so it is given in there. Okay. One more that see we have values in local way, or we can give a back peak that normally the value in the solar panel way, and we can give by meter square also. So if we are saying 1 meter square area and there, so how much cost is there? So we are selecting global here. Here there are different currencies are available. So euros, dollar, and all the stuff. Even INR is available here. So we let that one go. I don't know. Yeah. Okay. And the rates are also there, but these are older rates. Based on the data, these are very old rates right now. So that's what I am not suggesting regarding anything over here. See that INR rupees, euro showing 80 rupees right now, but it is not more than that. Okay. So we need to just for the testing saying we need to check some values what is happening. So I'm putting some values here. Quantity 6 already fixed over there because we have selected that. So let's the some unit price to the panel. So let's I'm giving some 10,000 rupees. Okay. So it is saying that 60,000 rupees is my cost. Now, what is the cost required for the support system? Let's say give some numbers here. 1,000. That is required for the support system. Now inverters we have used some inverters. So I'm giving some value here. Let's say 15,000. Okay. Now these values you can get it exact values also. Right now I'm just showing for the case that is I'm giving some values over here. If there is any other components are there, you can add what is the installation cost. Also, we can add that what is the cost, transport, and all this stuff. So we can put some numbers here all the time. So I'm not interested to show you the entire things. We need to just check what is the outcome we are getting. Okay. So based on these values, it is saying that 1,11,000 is required to install the things. Even installation, I'll add some values over here, transport or something. So quantity I'll put it 1, and transport I will keep it some 5,000 rupees. Okay, just random numbers I'm adding, nothing else. Okay, so this is the total installation cost we are giving. Some maintenance related things also we can say repairs or cleaning something we can give it yearly cost. Let's say I'm giving this 5,000 as a cost. Some security funds or insurance. We can add many things over here. So I don't want to add those things. So these are the parameters we can add it to analyze the economic things related to the solar plant. Now we need to go to the next step. So what is your project lifetime or time frame what you are suggesting, and what is your start year? So start year I am saying that 2025 you can put it. Now it is about to end, so let it be. And project lifetime is I'm saying 20 years. Sometimes people go with the 10 years or 15 years also. So we will change that one or we'll keep it that is as it is. What is the inflation rate percentage per year? So we can say something linear inflation rate, or we can say that there is some rate we can put it 0.5. Okay. And some income tax or other incomes also, dividends are the based on that one. So I'm not putting anything right now here. I'm just saying that okay, these are the things. Now we have invested based on this one. We have invested total 1,16,000 rupees in this particular plant. Now is it your own fund or is it from the subsidiary? So I'm saying that government giving me subsidiary. So I'm saying that 1 lakh rupees is from my own side and 16,000 is coming from the government subsidiary side. Okay, so based on that it is just giving you the graph, or you can add some loans also that we have taken some loans, so we need to calculate that one also. Okay, so next is the electricity cell. So is it a fixed tariff we are getting it or variable? So I'm saying variable, we have that one. So let's say for the peak tariff we are getting uh, power 3 rupees per peak, and off peak means whenever the demand is very high, the solar whatever the generation is there, it will be charged a little bit more. Whenever the demand is very low, still your solar is producing, so we don't want anything. So I'm keeping the value here 2 rupees and here 3 rupees. So just the numbers I'm providing. Okay, and here also I can add some, these are my off peak timing or something like that, or peak timing like that, just based on my requirement. Okay, now based on whatever the data we have provided, you can see the financial summary here. Especially the one parameter is the payback period, which is 8.2 years. Now what it's suggesting, you can here add some values also, what is the tax on that one and all for 20 years, so that will change. Now I just want to show you that what is this meaning of 8.2 years means whatever the amount you are putting in the solar panel, that 1,16,000, based on the whatever the tariff and all this stuff we are giving, it will be give you back the entire amount. Yes, we have considered maintenance also, right? Here we have put some maintenance also per year, so that is also considered in the system, and you will get the entire 1,16,000 back in 8 years, in 8.2 years you will get it back. Now, if you increase some or if you change some values here, initial cost or maintenance cost, it will always reduce and getting ahead of that. So, what is the baseline of the solar plant payback period? Now, this is showing you 8.2, but it is exactly half of that. Means it's 4.12 as per the literature. It is showing that in 4 years or in 5 years time span, you can get whatever the invested money, you can get it back from the solar. Now, it again depends at what cost government is charging you, that what is the electricity cost they are charging you. So there are some various methods are there. There is a power meter method is there. There is a net metering is also there. So different strategies are there from the MSCB. You should get it the information from the site and you can install accordingly. So for the maximum benefits, how we can do it. Okay, even if you have the some slopy surface facing south and you don't have any obstruction in between, you can ask MSCB to install the plant over there, and they will give you some rent for that space usage. These also available methodologies are there, but see, MSCB don't want to promote those things, because if you are using the solar panel that's plant at your home, means, for as I mentioned yesterday also, for the 8 months you are asking MSCB that I am free to go, I am not paying anything to you. But for the 4 months of rainy season, I am saying that please provide me the current so that I can utilize. So putting the renewable energy is little bit on the loss side for the electricity board, because we are generating our own, and we are asking MSCB to maintain each and everything connected to my side also. So that is the one of the fact. But as I mentioned, the government is promoting, means we want to shift to the renewable things. That is the only thing we wanted. You can do some analysis here. See, PVsyst can help you. There is a one Saur Urja scheme is going on. I don't know the exact name, that's Suraj or Saur Urja. That it is saying that 300 units you will get it off per month if you install the solar plant on that. Now you can, what you can do, you can that's what I gone for the 3.3 kilowatt. The other parameters of the costing parameters you can put it exactly, and you can find out how many years you can get it payback. Means analysis of that Saur Urja, it will be give you the idea that the government is utilizing only for 4 years the things. The remaining means government is not benefited till 4 years. After that, there is a beneficiation for the government also. And there is a question that if I am installing 1 kilowatt plant, what would be the energy entirely I'll get it? So simple thumb rule is there, 3.5 units per day. You can calculate in that sense. If I am installing 1 kilowatt, so we are getting 3.5, around 3.5 units per day. That is the cost. Now unit cost at in your area and all the stuff you can calculate. Normally it is 2 to 3 rupees up to 100 units, and after that it will change. So based on that much energy you are getting it from the from the plant, you can calculate based on that one also. So with the thumb rules you can calculate, with the exact calculations you can calculate the financial results. What it is showing that till particular 8 years you are not in profit. After that you are in profit, you are getting some money, and you can say that what is the profit percentage after 20 years. Show you in that sense. Okay, you can see there this green part, it's 255.6%. Means whatever the investment amount is there based on the grid connected system, after 20 years if I keep on doing same things with the inflation rate also, I have mentioned something over there. If that follows, then we are getting 255% profit based on your initial investment today in 2025. So that is the important calculations we required it. for the calculating of the solar plant, because everybody want that. If you are a plant seller or something like that, or if you want to suggest somebody that I can tell you that what is the how many years you can get it back, so you need to do the precise simulation for that one. All these things I'm showing it as a case studies, but precise simulation means where the plant is there, where what are the objects nearby, what are the far side, what is the exact location of the plant, latitude and longitude. Based on that, you will get it properly. Then also this is the important one. What is the carbon balance? You can see that if I'm keeping my project years, making is 30, so I'll making it 20 again. So based on the India one and all this one, so the carbon, you can see that ton CO2, 6.6 ton CO2 we are saving from that one. That is the carbon balance, we can say. Now there is a concept called carbon credits. So that is another means we can earn money from that one also. So you can see that particular things also from here. So how many carbon credits are there, what is the cost of one solar credit, and you can get the money from that one. But for the smaller plant, we won't get any beneficial for that one. But for the bigger plant, say 10 kilowatt or more than that, we are getting little bit benefits from that carbon credits also. You might heard, means just a topic is there, that's what I'm telling you, that here it is saying that 89.549 tons of carbon you can save it based on that one. You might heard regarding one government scheme, that zero carbon credit. So zero carbon credit is practically impossible, because you can industries are there, those who are using some electricity, they are producing some carbons. But what is meaning of zero carbon credit? If you have the industry, you know, you can do the carbon credit analysis or audit of that particular thing, and you can check that how many carbons ton per year you are producing, and you can install the plant of similar size at different location also. It is okay, not necessarily you have to install or inside your industry or inside your company area. So you can get the carbon credit from that particular one. If you are getting the zero carbon credit, it is good. That's what the government want from us. Okay, so this is the detailed one. Again, we are not going inside that one, these things. So I'll click it on OK. And this is the way we can do some simulations, grid connected simulations on PVsyst. Um, you can generate the report again, because we have put some economical one also. So let's see what are the economical things that it's showing me inside my report. It is too much time, because we have added much more data in the system today, financials and all. So let's see what this report tells you about in a short. Okay, so I'll just zoom this particular one. So this is 3.2 or 3.3 on the rounding up the plant is there. So these are the summary one, where we have installed it all. Our these are the PV model characteristics. Again, we have selected one model from one of the manufacturer randomly, 545 watt peak. So based on that one, 6 models are there. The losses we have considered, some default losses are there. And these are the horizon. You can see that there is a far side shading been considered here. There is some object shading also there. So this is the object part which is there. We have considered one tree. You can design the object whatever you want. See, people are ready with the particular design, that okay, my building design is like this way, my nearby object designs are like this way. So based on that, all the parameters they hold, and then they start designing this particular near shading system. So this is always beneficial for you to understand what is the effect. So you can see that this particular part being shaded after some time, so in the year. So these are the overall balance and main result. What is the grid dumping and all this stuff. I'm interested in the financial one. So these are the loss diagram. We have considered some losses. So based on that, it is considered some loss. Yeah, inverter loss we haven't considered, but still we have to consider some losses based on that one. This daily input and output diagram, yes. Or useful out energy. We can see that what is the watt per this thing. This is the system, which is this is a plant. 6 panels are there. Then there is an inverter and there is an injection point. And this is the financial analysis. As we have seen that what is the cost of the panel. We have considered 10,000 for 500 watt. It's a lesser cost, but still we have considered that. And based on the other cost for the 20 line, some depreciations also we have considered. So return on investment is, I think I have read it wrongly in the report. It's 155.6%. So you can see that if you invest this much amount in the solar, you are getting 155% return after 20 years. So after 8 years, you start gaining the output, nothing else. So these are the saying. Yeah, it's saying 255.6. I don't know what is wrong with this one. After 20 years, it's saying the 255, or maybe it has taken some average regarding that one. What it's saying, which is good in terms of. So your yearly profit, you can see that in the first year, whenever we are installing the plant, there is a huge investments we are putting in that one, more than 1 lakh. And then every year we are getting some benefits from the plant. That's what it's saying, that first year is down and then every year is good. And based on the 8 years calculation, so these are the 8 years, and after 8 years we are getting benefits from the plants are very good till 2045 might be. That CO2 emission balance we have seen. So this is the entire report we can generate from PVsyst. Now you can imagine that if you are actually the panel seller, or you want to contact one of the panel seller and tell them that okay, we have one software which can give you the answers all the questions whatever the people are asking. So this is the one solution we can provide it to the people. Here the main results, you can see that what is the investment and all the details are there. Now we are interested in that estimation part. So I'll just close this one. And in the energy management, we are interested in this one. So you can see that estimation part also, that is the P52 P90, that particular estimation part per year. So it is saying that 5614, P90 says 5418, P95 says these are the algorithms, and it is saying that this is the 5355. So based on all this stuff, so our simulation says 5641, that is we have considered for the calculation. If we are getting little bit less, so we are getting little bit less outcome from that. So there is a 174 kilowatt units variability is there from the actual one. So this is the way. Now how to use this particular software for research purpose. Especially this is the, as a faculty we are interested in the research. See, as I mentioned yesterday, there are many ways we can add up the things, we can compare the things, that is also important. We can do some shading research, that shaded part research. We can do some what you can say, what financial analysis research, that how much time span we required to get it back. If we are setting up the 1 megawatt plant, or if we are going for a little bit lesser quantity, what is the installment required, what is the cost required. So based on that also we can do some research. And then all the terms are possible here. Comparison is one of the things that we always do, that if I'm using the monocrystalline instead of that one, if I'm going for the polycrystalline panels, the panels are a little bit cheaper. So what is the effect? So all this efficiency related part is taken care by the software. Means I don't need to check that what is the efficiency or 14% or 15%. It is been taken care by the software. If there are some losses, as I mentioned that every day there is a if panel gets heated up, it is losing the efficiency. So those losses also been considered in the calculations. So that makes this particular software little bit on the higher side or good side, that can estimate the output from the solar plant very well. So that is the important parameters. And always you can compare the two softwares also. You can do some analysis in the PVsyst. There is a system advisory model, as I mentioned yesterday, SAM. It is well known as a SAM. You can search it online. Or there is another system is PVlib. You can always compare these three softwares outcome for the same plant, and you can tell that what is the exact value. If you know the exact plant output, you can come up with that solution also, which software is giving you closer values with the this one. I'm sure that the PVsyst will be there, because I know the other softwares are not come up with this particular shadowing effect. We have to consider that, means this percentage effect, but not this much precisely. Even the thermal effects and other LID effects are not being considered, or in that precision is not been considered in the other softwares. That makes the PVsyst little bit higher edge, or giving the advantage over the other simulation softwares. So if you have any doubts or queries, I'm here to answer that. Okay. See, as I mentioned, I'm giving the case studies now. It's your duty to go inside the software, try something, add something, other objects, add something. Yeah, well, as I mentioned, we will see that one also. So orientation part, that we will change it today. We will make the seasonal adjustment tilt, and we will say okay. And say they apply to all orientations. So orientation parts, as I change it, and let's see. Yeah, there is a near shading is there. We need to generate that table also. Now you can see there is a change in this particular one, and we can see that what is the effect on this particular one. I don't think so. The other parameters we need to change. Uh, I hope you remember the numbers, or I remember the numbers now. So let's see, the economic evaluation is, the numbers are there itself as it is. Yes, now you can see that. Oh, okay, the payback period goes higher on side. It should be go lesser. Uh, I think what goes wrong, because I have selected 10,000 per module, so 60,000, 36 for the support system. Okay, okay, that numbers now we need to be very much careful about, and we need to put such a way that, see, if we change the orientation, then we should get the good results for that one. Yeah, obviously our numbers will goes higher side, but we should get the good result based on that one also. So let's see that the change in that one. Is there any change we are observing? No, it is showing 10.4 years. So these are the numbers. We need to be very careful about the selecting the exact numbers to get it. The system, grid connected system with the two orientations, it should provide you the good outcome. So that particular things you can try out with the trial version, 1 month free, and you can definitely publish the data in that 1 month. That would be the good thing for you. You can improve this one. Let's hope that, is there any changes will be there. Yeah, you can see that Yeah, I'm just making some changes over there. Okay, so instead of 3 rupees, if I make it 5 rupees, so it is saying that 4.8 years, which is almost close to the whatever the numbers showing in the literature. So, based on the actual data, you can check what is the required data and what is the actual prices. You can put it in the software and you can get the results. That would be the best thing to simulate the models from this one. Okay, here it will just give you the summary that what is the summary based on the that 5724. Yeah, that number changed. It was before it was I think something 5 or something number is there kilowatt hour per year. It is changed due to the orientation. If I change the orientation and even if I change the angles, it will change it based on that one. As it is a grid connected system, we are not interested in the tracking and all, but still we can always check. Yeah, I'll make the another orientation. Let's run the simulation just to check what is its effect. And especially I wanted in the economics as it is changing 4.6 years now, a little bit better compared to the previous one. And if you check the summary, it's 5840, which is also improving. So these are the things we can do it with the PVsyst. All the reports or all the graphs are available. The various graphs are available. You can see here what are the predefined graphs are there. You can select that. You can add that. What is the array voltage distribution and all. So the various analysis related graphs are also available. So even if you want to publish the analysis report of a particular solar plant, a known plant to you, that is also possible using the PVsyst. This is the software. So I think I'm done from my side. So because in the trial version, as I mentioned, there are not much more things are given. If you check it online with some videos, you will see that people are doing the Google Maps and all additions. Even that plant your panel numbers, let's say cost, that also we can predefine in the full version. Means we can actually add the panel, we can actually give the cost also, and it will automatically no need to give the cost afterwards. It is automatically calculating the entire things. So that is also available here. We have to put it the cost, nothing else. So these are the things from my side. Any questions are there? Then I'm happy to answer. Anything related solar, I'm happy to answer. I think it's enough regarding PVsyst. If you have related any queries, also you can ask. If you want another simulations of different plants, let's say doing something also, we can try out today. So anything from your side? Oh, okay, okay. I'm tried to get the answer. Let's see that today. Okay, so pumping, I try to get that answer, but still I haven't find anything. Let's try out today. Means that particular error, I try to find out the answer. I don't know where the data is going wrong. So let's check it today. So orientation, I'll keeping it as it is. I don't want to change. Water needs, we need to fill some level. So I'll put it static level as 1 meter. Mm, okay, it is I think asking minus. So okay, static level is this one, and pump level is pump depth is this one. So whatever the pump depth we need to store, it should be the less than the 1 meter. Mm, okay, the pipe choice, I'll select something, and piping length should be the less than the 13, should not be like that. Number of elbows, I'll keep it 2. Other frictional losses, I'll keep it as it is 0 right now. Water needs and head definition, so yearly average whole year needs, let's say 3. Okay. So anything else required here? No. Here -1 is okay. Still, it is showing somewhere. Please define the specific drag down for this well. Okay, where is the drag down one now? Yesterday, I think we have defined it. Maximum flow rate is not required. Okay, so static level, even if I'm changing this, no, the error is regarding the different one. Okay. It's let's define the drag down level as 1 - 1 meter per meter cube. It's okay. And please define the tank size and diameter. Okay, so storage tank volume, we'll put it something like say 550 meters diameter. I'm not good in this particular one, so I'll just putting some values over there. And the remaining things are as it is. I'm keeping here. Pipe length should be at least as long as the level is saying 15 today, so I'll make it 15, and it's okay. So water needs are there. Okay, so here also we will go for the some pumping system. Let's say 1.2 kilo pump at pump. The control strategy is not defined, so let's define the control strategy in this very design. So we'll go with the higher wattage panel. And okay, it's still giving me that error. It is the pump minimum head is over the maximum static pressure needs. Mm, I don't know why it's showing me that error, because even if I change something here, it is not doing anything. Even if I'm going from higher pump side, it's not showing me anything. So I tried to search it online also yesterday, but I haven't got anything on that one. Let's see, going with the plant power. Oh, is there any effect? Let's say 5 kilowatt. It is not accepting anything. So this particular error I'm unable to sort out yesterday also. Tried it, but it is not getting. So once the system is not there, so we can't run the simulation. So we'll try out, and if something is there, I'll post it on that group. What how to solve that one? I'll post it on the group. This area means this pumping action. I have never checked it. I deal with the grid connected or standalone system, but pumping area I never checked it. It's a additional feature, so I just gone through that one 2 days back, but it is not giving me the proper answer. Okay, so any questions, queries are there? I'm happy to answer. Yes, any queries, questions? Okay. Yeah. Mhm. Mm. Yeah, thank you very much for giving me this opportunity to deal with the PVsyst again after a long time. And definitely, the work in the system, then only you will get the ideas, then only you will get the output. Thank you very much. And thank you. I'll close. Thank you.